What role is Intel playing within the big data world?
That's a very broad question. It's a very interesting one. And perhaps the best place to start is by saying to us, big is the least interesting aspect of the data that we're seeing today in its explosive form. What makes it really interesting to us is that it's unstructured, it's moving very fast, it's real time for the most part, and it comes from a whole diversity of sources. Sources that Intel has had a processor or some ingredient of some kind in for quite some time. So Intel has this, comes with this breadth of presence in the client side as well as on the server side, in the data center as well as individual computers, PCs, and laptops and devices of all kinds. And what we find is that combination of user experience at the mobile, social edge and the sensors that pick up data from the real world and pass that on to cloud-based data centers all take advantage of Intel compute engines, cores, if you will. And those cores are central to the whole big data processing framework, right? So when we look at it from the perspective of a semiconductor company, we see cores everywhere, there's silicon everywhere, but that silicon everywhere makes almost a platform on which to build analytic solutions, to bring analysis as a mainstream activity to that data, whether it's at the edge or in the cloud. So for us, Intel's involvement in big data is almost a natural outgrowth of the fact that we have silicon everywhere, that silicon computes the data that comes from everywhere and is used by businesses and individuals. And what we'd like to see happen is for that data to turn into insightful, actionable intelligence. And so Intel's presence in the word intelligence is no accident. We really take that very seriously.
So flipping that, how is big data shaping Intel?
Well, so we'd like to see this as more than just another way of selling the same products into a different market. This isn't just a market segment, it isn't a particular application, it is not a niche. We see big data as a secular trend, and that secular trend shapes the way we think about future microarchitectures, about future silicon design, as well as the software that we build to enable that silicon in systems that are either used in client devices or in the data center. Right? So for example, here at this event, we have a number of people who are looking at workloads that might be imagined in the year 2017 in order to define a long-range plan for our Intel architecture team. Right? So we have to look ahead that far to be able to define and develop and design products that can then go into our very extensive fabrication process that's been optimized over the last few decades to deliver at the scale that can serve the needs of customers today.
Can you talk about how big data is being used by Intel within something like its, the application of it, within something like its manufacturing process?
Sure. So one of the things that we see as very important is the instrumentation of real-world processes to make them smarter. So the most logical place to begin is in the manufacturing process within Intel. In many ways, Intel is the most advanced manufacturing company in the world because of the sensitivity of the processes that we use to work with, and the fact that you have to take seismic variations into account into designing the fabrication and the plant is a particularly important source of data that needs to be analyzed to further tune that process. So we generate terabytes of data a day from the manufacturing process that needs to be analyzed. We're using large-scale data analytic tools today, and we're hoping that as Hadoop matures and that other big data analytic platforms mature, the cost, the scalability, and the capabilities increase to a point where that becomes a lot easier for us than it has been. So that's just one part of it. Intel IT serves the needs of the enterprise and the business units within Intel, and Intel IT serves if you will, a data analytic platform for a number of business units to use for data mining and for a number of analytic functions that every enterprise does. In addition, We have a consumer-facing app store that delivers applications from which we can use a combination of behavioral analytics and customer data and website traffic to do the usual kinds of traffic analysis that you would expect at a web-facing property. So a number of ways in which Intel's using big data.
You mentioned analytics a number of times in there. Something I've heard is end-to-end analytics. What is that, and how do you see that developing over the next couple of years?
It's a term that we've started to use to talk about analytics as not a particularly localized activity, but as something that you might imagine having a locus, whether at the edge or in the data center. As devices get smarter, and you can imagine a smartphone is but one instantiation of a smart device. There are sensors, there's video monitors, surveillance cameras, traffic management systems that use that video data, all of which could have analysis done locally to some extent before the data that's captured from those endpoints gets moved and transferred over to a centralized cloud where further analytics could happen. So if you'd imagine sort of a tiered hierarchical model for data as it's collected from the endpoints at the sensors, some of which gets processed at the endpoint and some of which gets passed through on to a cloud data center for further analytics. Then you have an end-to-end where analytics is not just at one place, where it doesn't just come to where the data sits or where the compute sits, but the compute and the data are essentially intertwined regardless of which device or which system they happen to inhabit at any given time.
So, last question for you.
Sure.
The notion of processing at the edge, how important is that? Because a lot of times when I hear discussions about cloud things, we're talking about taking the data and just putting it out, right? And the processing happens there. But on that edge case, how important is that going to be, do you feel?
I think it's going to be a combination. It's hard to say, it's hard to predict where that continuum darkens, if you will, towards the edge or towards the cloud. And I have to believe that it depends specific workloads in specific industries and types of use cases. So one of the things that we're really excited about is that as Hadoop and the ecosystem around Hadoop grows, the applications of Hadoop or other open source analytic platforms like that will stretch the boundaries of those use cases. We'll find new applications in much the same way as Linux 10, 15 years ago started to push the boundaries of where operating environments and systems could be developed, and intelligent systems could be developed. And so to us, having intelligent systems, particularly with over 1 trillion devices now connected to the internet, would suggest that anything that has an IP address and an actuator that does some kind of work in response to a signal or a control function is a source of both data as well as, in some fundamental way, intelligence, because it's smart. It senses the environment and does things in response to what a broader system is able to communicate back to it. So yeah, I think it's really important.
Interesting. Well, thanks for being with us.
Of course, happy to be here. Thanks.